Well, welcome back, everyone. Thanks for coming. What I'd like to give you is a very big overview of how epidemiology has evolved over time, the methods that we use today. We owe to people in our past who developed these methods, refined these methods, to allow us today to measure associations, and from those associations argue that some factor might be causing some outcome or some disease. Now, much of what I'm going to be showing to you is described in more detail in your textbook, and much more detail can be found on the web. So Google away after I finish this particular section and learn more about some of the people that I'll be mentioning as we go through this section. The oldest record I could find of a study that involved epidemiology is a section of the Bible when they talk about the book of Daniel. Daniel was one of those young Israelites, Jews, who was taken away and carried off to Babylon during the Babylonian captivity, which was about 600 BC. And the goal was to train some of these Israelites to become involved in an advisory role in the king's court. So Daniel and his colleagues were essentially put into a training program. And one of the benefits of that training program is they were offered the same food, wine that was offered at the king's table. And for religious reasons, Daniel and some of his colleagues resisted eating that particular diet and would rather have a more traditional diet. So this is a quote from the book of Daniel, when he tried to essentially argue to doing a study to examine the benefits of two different diets. So speaking to the steward of the king of Babylon, he said, "Please test your servants," meaning myself and my colleagues, "for 10 days. Give us vegetables to eat and water to drink. Then see how we look in comparison to other young men who eat from the royal table." After 10 days, they looked healthier and better fed than any of the young men who ate from the royal table. So this is the classic example of an epidemiologic study, comparing two diets. Daniel and his colleagues were given one diet made of fruits and vegetables. Other men, a comparison group, were given another diet based on the food and drink that was given at the king's table. Both groups were followed for 10 days, and then some judge subjectively evaluated the two groups, looking to see which group looked fitter, which group looked healthier. And in this particular study, the diet based on fruits and vegetables appeared to be the winner, in the sense that those people who partake of that particular diet had better outcomes. So epidemiology has been around for a long time, almost 3,000 years if you trace this back to the time of the Babylonian captivity. About 200 years after that time, the Greek physician Hippocrates, the father of modern medicine, was training people in medicine, and his students took his teachings and wrote them down and into a series of writings, one of which contains the following quote from Hippocrates. He says, "Whoever wishes to investigate medicine properly should process thus. In the first place, consider the seasons of the year and the effects of each of them. Then the winds, the hot and the cold. One should consider most attentively the waters in which the inhabitants use, and the mode in which the inhabitants live, and what are their pursuits, whether they are fond of drinking and eating to excess and given to indolence and are fond of exercise and labor." Hippocrates was pointing out that there are characteristics of people, characteristics of the environment that they live in, that influences their chances of developing particular disease. Epidemiology is aimed at trying to identify those determinants of those diseases. Well, moving ahead roughly 2,000 years, maybe the first real involvement of epidemiology in the method goes back to a British investigator by the name of John Grant, who published this following writing, "The Natural and Political Observations mentioned in a following index and made upon the bills of mortality." The bills of mortality were routinely collected and reported results of who was dying and what they died of. John Grant used those weekly counts of death to look at associations between characteristics of people and their causes of death. He reported yearly and seasonal mortality trends. He found out what were the common and the uncommon causes of disease. He noticed that men were at higher risk of dying than women. The key point I want to stress in John Graunt's work was the use of routinely collected data, collected for an entirely different purpose, just reporting who was dying and what they were dying from. And from those data, try to glean information between potential associations, between determinants and the mortality and the causes that people died from. About 100 years later, a Scottish physician, James Lind, was perhaps the first person to perform an experiment, a clinical experiment on individuals. He performed an experiment trying to identify the appropriate treatment for a disease called scurvy. Now we know today that scurvy is caused by a deficiency of vitamin C in a person's diet. But at the time in the 1700s, when Lind was treating such people on British ships, he decided to do a study in which he enrolled 12 people who had been diagnosed and were sickened with this disease of scurvy. And he decided to divide them into 6 treatment groups, each containing 2 people. All 6 groups, all 12 people, received a common diet. But each group received something in addition to that. One group received a quart of cider. One group received the elixir vitriol, which is sulfuric acid. One group received vinegar. One group received seawater. One group received a spicy paste made of mustard, I think, and garlic, along with some barley water. And the last group received 2 oranges and 1 lemon. And then he followed those people over time to see which group would recover more quickly or recover at all from this disease of scurvy. And the winner was the group that were given the 2 oranges and the lemon. The key point, this is an experimental study. Unlike Daniel, when he was making his plea to the steward of the king, where he said, let us have this diet of fruit and vegetables and let these other people have the traditional diet that comes from the table of the king, there the individuals in that study decided which group they were going to be in. One group wanted the diet of fruit and vegetables. One group wanted the diet that was given to the king on his table. In James Lind's study, Lind decided what particular diet each group got, not the individuals themselves. So the key decision point here, or the difference point here, is that in an experiment, it's often the investigator who decide which treatment a person receives, not the individual themselves. We'll talk more about experimental studies and other study designs in the middle third of this particular course. But next I'd like to bring you to attention of 2 major players in the field of epidemiology and the development of epidemiology who lived at the same time and worked together. One was William Farr. He was essentially the chief statistician for Great Britain. He was the statistical superintendent of the General Register Office of England and Wales in the 1800s. He was responsible for collecting and routinely distributing information about the health of people, usually by reporting mortality figures and causes of mortality for different regions of the country. One of his results referred to a cholera outbreak in London that occurred in a particular time in the 1800s. And he published weekly reports describing the occurrence of that disease, how many people were dying from cholera, and they broke them down by the age of the individual, the sex of the individual, the temperature of the day in which they died, how much rainfall, how much wind, the day of the week, elevation, crowding, property value, linking the occurrence of disease, dying from cholera, to these potential determinants. Now I want to draw your attention to one of these determinants, elevation. Because at the time when Farr was making these reports, he believed that the cause of cholera was essentially bad air, polluted air. That was the common theory of the day. It was called miasma. The way you contracted this terrible disease that might lead to your mortality was by breathing into your body harmful particles. Farr believed that that was true. You would expect that people who lived at low elevations, where the air might be denser, were more likely to breathe in these harmful particles than people who lived at higher elevations, where maybe the air was less dense. So one of his reports showed that the mortality rate of dying from cholera was greater for people living near the River Thames with a lower level of elevation, and higher farther away from the River of Thames where the elevation was larger. He found that association between elevation in which a person lived and the rate of dying from cholera. And that supported the miasma theory. But at the same time, Farr was reporting those results. One of his colleagues living at the same time in London was a physician, an anesthesiologist by the name of John Snow. Now, as an anesthesiologist, Snow knew something about gases, and he didn't believe that it was the bad air that was causing people to contract cholera and to die from it. As a physician, he cared for people who contracted cholera. He noticed their signs and symptoms. He noticed they would complain of belly pains. He believed it wasn't the air, it was the polluted water that they were drinking. And so what Snow was able to bring to the table was prior knowledge, expert opinion, beyond the data to suggest a causal relationship between not polluted air but polluted water as a potential cause of cholera. And using data from Farr's reports, he was able to do two important landmark studies to convince people, including Farr, that it wasn't the miasma theory that was true, it wasn't the polluted air, it was the water. One of his studies was the Great Experiment, as it was referred to, of 1853-1854, where using data that Farr published, and Farr published data showing the mortality rates of cholera for areas of London served by different water companies. Some of these water companies took their water from the polluted portions of the Thames River. Others took it from a less polluted area upstream from London. It was Snow who noticed that people who were receiving water from the less polluted sources had a lower mortality rate than those who were receiving their water from the polluted areas of the Thames River. So using data that Farr had furnished, Snow was able to argue convincingly that it wasn't the air, it was the source of the water that might be the cause of the cholera. In addition to that, he investigated one outbreak of cholera in a particular neighborhood of London, the Soho district, 1854. Reading the results, the weekly results that were reported by Farr from his office, Snow noticed that one region of London, which had essentially been free of cholera for the previous weeks, suddenly had a huge outbreak of cholera. And based on his theory that water was the culprit, Snow visited that region and went door to door trying to find out where people lived who had died from that cholera, and noticed a clustering of deaths near a particular pump in that area, a water pump that would serve water for people living in that area. And by his interviews with people in that area, he was able to build up an argument that the source of the cholera was that particular pump. And he argued with the officials in that area, and ultimately the pump handle was removed, hopefully to resolve that particular problem. So Snow and Farr show the combination that's needed to do epidemiology and clinical epidemiology research. On one hand, we need hypotheses, suggesting potential risk factors for causing disease. That's what Snow brought to the table. As a physician, as an anesthesiologist, as someone who was caring for people who would suffer from cholera, Snow believed that water would be the potential culprit for this particular disease. But he needed data to support that, and that's where Farr came in. Farr, as essentially the statistician for the country, was reporting data on mortality from cholera for different regions, and Snow was able to use that data essentially to build his argument convincingly that water was the cause of the true cause of cholera. So what we need to do good epidemiology research is a combination of two things. Good hypotheses, often based on prior knowledge, often based on previous studies, and good studies, good data. And that's where the quantitative methods course will come into play. How do we use these data to build associations, to argue that this particular risk factor might be the cause of that particular outcome or disease occurring? So that's the big history in terms of epidemiology up to this century. There's just a few other people I want to mention that are mentioned in your textbook and pertain to lectures that we'll be giving in this particular course. The textbook refers to a statistician, Austin Bradford Hill, and refers to one very important study he did in the 1940s, looking at a treatment for tuberculosis, streptomycin. It was perhaps one of the earliest modern epidemiologic studies. Well, I mentioned that James Lynn did a clinical experiment. What was Lynn's study? How was it different from Bradford Hill's study using looking at a particular treatment for tuberculosis? Well, what Bradford Hill's study involved, what the streptomycin study involved, is first of all enrolling people who were homogeneous with respect to disease. There were different potential treatments for tuberculosis at that time for different types of tuberculosis, but Bradford Hill enrolled one particular group of people. One group received just bed rest, the other received bed rest plus this new treatment, streptomycin. The key points that I want to stress about this study that we will talk about later in this course that make this study particularly noteworthy is that Hill had to address certain issues that pertain to most modern experimental studies. First is the ethical problem. Who do you give this new treatment, streptomycin, to, and who do you don't give the streptomycin to? Remember, in an experiment, it's the investigator who decides how a person's being treated, not the person, not the person's physician. So Bradford Hill was essentially deciding which group of people would just get bed rest and which group of people would get bed rest plus streptomycin. He essentially used a random device, a series of random numbers, so that roughly half the people got streptomycin and half didn't. And to argue that that was ethics, he only had a certain supply of streptomycin to give, enough for half the people in the study. And if you don't know what the best treatment is for one person, streptomycin or no streptomycin, then a coin flip, a random device, is an ethical way to decide who should get this treatment and who shouldn't get this treatment. So ethics is something we'll be talking about when we talk about experimental studies. We'll introduce this notion of equipoise, a word that we'll explain later on. Another feature of this study was that Hill enrolled homogeneous people who were very similar in their severity of disease, so that any outcome you receive in one group versus another group might be attributed to what was the difference in the treatment assignments, not to the types of people who were receiving that particular treatment. As I mentioned, he used a randomization device to decide which group would receive streptomycin and which didn't, so that each person had roughly the same chances of falling into two groups. And we'll talk about the importance of randomization later on in this course. And finally, he introduced the notion of blinding. The outcomes were determined by looking at X-ray films. And the people looking at the X-ray films, the investigators interpreting these outcomes, were blinded in whether this person received streptomycin or didn't receive streptomycin. Therefore, the knowledge of the treatment couldn't influence the decision to call this person positive or negative in terms of the outcome that was being determined. We'll talk more about clinical trials and each of these features later on in this course. The last person I want to mention is a colleague of Bradford Hill's, Richard Dahl, who in the 1950s did a series of landmark studies looking at the association between smoking and lung cancer. The first was a very large case control study where they enrolled people who developed lung cancer and people who didn't develop lung cancer and asked them about their previous smoking habits. The second was a prospective cohort study where they enrolled people who were free of lung cancer. Smokers and non-smokers, followed them forwards in time to see which group developed lung cancer more rapidly, more commonly. Those two study designs, case control studies and prospective studies that Richard Dahl and his colleague Austin Bradford Hill used in those studies will be the traditional epidemiologic study designs that we use, and those will be things we'll be talking about along with the experimental studies in the middle third of this class. Well, the last thing I want to mention, the last thing that's in your notes that talks about the historical development of epidemiology, is a study, not a person, the Framingham Heart Study. And in my next section, I'll give you a little bit of history about the Framingham Heart Study and explain how we'll be using data from the Framingham Heart Study in this class to get as examples in some of our lectures, but also in our assignments so you can get familiar with using those data to answer questions that might be pertinent in terms of epidemiology. So I'll stop here and look forward to seeing you next time. Have a good day.